The information below is valid for a 10-acre site being sized for a retention basin. Consider the hyetograph and accompanying information. Infiltration occurs for the first 30 minutes at an even rate of 0.03 inches every minute. Transpiration is also constant at a rate of 0.01 inches per hour. Depression storage and surface storage at the area in question includes 5,000 gallons of available capacity. If the depth of the retention basin on site cannot exceed 10 feet in depth, what is the required size of the retention basin in square feet? So over here we have our hyetograph. We can see the y-axis is in inches per minute and the x-axis is in 10-minute increments of time. Now there's nothing in the problem statement that would necessarily make you think, oh, I should search for these words. But there is a section in the Civil Reference Manual under section 6.5.8.1 titled Surface Water System Hydrologic Budget. Again, I don't know what you would actually search for, but it might be helpful just to know that this exists in case you want to study it or review it, so that you know where it is if you feel inspired to find it during the exam. But even without it, we can go through the terms that the problem statement gives us one at a time and find our retention basin that way. So the first thing we're going to do is find our rainfall volume in cubic feet. And while we're doing this, we're also going to account for the infiltration at the same time. So we can see that infiltration occurs for the first 30 minutes at an even rate of 0.03 inches every minute. So let's just go to our hyetograph and cross off 0.03 inches of rain for the first 30 minutes. What that shows us is that the first half of the hyetograph won't actually contribute any buildup to the rainfall. But we can still sum the rain that occurs during the second 30-minute period. That's going to be 0.04 plus 0.02 plus 0.01 to give us a total of 0.07 inches per minute. Now if we multiply by 10 minutes, this will bring us to 0.7 inches of rain over the whole hour that are not infiltrated. From there, we can unit convert to get this into cubic feet. So first, we'll multiply by 1 foot over 12 inches. Then we'll multiply by the 10 acres on the site. Then we'll multiply by the conversion of 43,560 square feet per acre. And we can multiply these out and cross out our overlapping units to get 25,410 cubic feet. Next on the list is our transpiration. We can see that this is just a constant at a rate of 0.01 inches per hour. So all we have to do here is write down that value of 0.01 inches per hour, but the hyetograph is 1 hour to begin with, so it's really just inches, and perform the same unit conversions that we did to get the rainfall volume in cubic feet. And that's going to give us 363 cubic feet. Finally, we can account for the depression storage and surface storage. So we can see that we have 5,000 gallons of available storage capacity on site. That capacity will need to be subtracted away from the amount of rainfall volume as well, since we will need that much less detention basin. So 5,000 gallons times 1 cubic foot over 7.48 gallons, and that'll give us 669 cubic feet. Now that we've accounted for all of our gains and losses at the site, All we have to do is sum them up. So our rainfall volume is going to be a positive number. And all of these values are in cubic feet. Again, transpiration is going to be a negative value. And depression storage will also be a negative value. Solving this, we get a total of 24,378 cubic feet. And now that we know the total rainfall at the site that is left over, we can design our detention basin. So if we know the depth can't get any greater than 10 feet, we can simply divide our total volume by 10 feet to find the square footage required. And that's going to come out to 2,437.8 square feet. The closest answer to the left is the first one at 2,450. So this problem doesn't require the reference manual, although it might be helpful to you to know that the surface water system hydrologic budget page does exist, just to review it. All you have to do is grind through unit conversions on this problem, and just make sure that you're accounting for infiltration properly, since it's greater than the amount of rainfall during the first half of the hyetograph. And that's it.